Hashim. This is my chair in question. I designed it, spiral base with a folded top that fits in the base plate of the seat. This is the structure I used, cardboard folding method. I folded it. The rule is that the force transmits this way, and this is the force vector, which is when we fold transmits the force, and this is the center origin here. And this is one of the models I made, and I made it stiff by this structure. We put that in, it produces webbing, like extra stiffness, and you fold it in, and you fold like this way, and it goes in, and this is the top, which because being a model, I cut it so I wouldn't have the problem with it. Now, this chair's weight is 1.8 kilograms, cut and fold. Come here, have a look. This is the big piece of cardboard I drew on it, and then I cut out one single sheet before I folded it to make it look like extra lightweight, modular, foldable furniture. Dimensions are here, and I designed like this chair using glue and cardboard, and it's got spiral four-sided base which has got a clockwise moment creating torque. Top plate and the base plate are in shear force, shear stress. The panel on top resists torque by shear force, thus making the panels strong. The force vectors I showed you, they go through here and this way. This is the direction vector, and this is where the force is transmitting. And my weight was 90 kilograms, which I changed into newtons by multiplying it by 9.8. And they are this vector and the force are at angle theta, which basically joining at the origin at the same time. And this is where they produce torque because of the twisting action. If you look at it, it's twisting. Now, this is the design of my chair. Before I started, I drew it. I drew several options, and then I worked out the forces on the chair. There is the equation of torque. I had to work out maximum torque. Once I worked that out, the equation, I could now figure out how to design my chair and where the center should be, the origin of my panels. And once I folded them like this is the model. You can see that, and I actually wrote force and force vector on it. This is the thing I come up with. The bottom, you can see, it's like an hourglass shape. It's technically an hourglass. So this is my prototype model, and this is my folding exercise. Ultimately this, which I'm now going to show by sitting on it. My husband tried it too. He's 110 kilograms. I'm 91 kilograms. So I'm 1 kilogram over actually. And once I done that, voila. Take the picture here. Come here. Up here. I originally put tape on it, which I took it off, so it destroyed a bit of a material off, and I took it. So this is the structure I have, as I suggested. So it took me 3 prototypes to make one, and the torque equation to work it out where the spiral would be and the dimensions for this chair, and help me creating a strong chair which can be now made in other materials as well, like acrylic and steel, using CNC, and if you do a SolidWorks, that would be sheet metal for steel. Thank you. and the weight of this thing is 1.8 kilograms, and I can lift it by hand if I want to. So it's very, very lightweight, even a child can lift it.